All right. Thanks everybody for coming. I'm Shane Grieve. I'm one of the organizers, along with another great group of very, very dedicated people that have been working to put this show on, and it's great. And I'm really appreciative, and so good to be here. So today we're going to talk about computers from around the world. So I've got a fairly diverse collection of machines that come from different places of the world. So that's sort of my thing. And there's some considerations and some things to think about when you're sort of trying to go down this route of collecting different machines from different places. So that's what we're going to talk about today. We can make it a little bit interactive. If you have questions, just sort of raise your hand, let me know, and we'll stop and talk about it through that. So anyhow, thank you all for coming. So we'll just go through an introduction. We'll talk about how to find some of the machines, power, video, and other considerations, and then we'll just dig into some stories behind some of the machines I've got. I have the most detail about the Soviet machines because I think they're a little bit more interesting than some of the others, but we can talk about any of them. So about me, so love to travel, and any opportunity I get to travel, I take it. Started collecting computers from around the world about 20 years ago. I've got machines from Europe, Australia, Asia, former Soviet Union. I'm also a big glider pilot and flight instructor, so if you haven't flown gliders, you all need to go fly a glider. And my day job is in cloud security. I'm an AWS security engineer. So that's a little bit about me. So, how to start finding machines. So all of my machines that I have come back in a suitcase with me. So a little bit different to some of the others, but there's other ways to get them without traveling. But all of mine, I've dragged back in a suitcase. But the key is, if you have a trip coming up and you are traveling, start planning early. So by planning, what you need to do is you need to start identifying the targets, the machines that you want to get. You need to research a little bit about the computing history in the country, because what you find will usually surprise you. There's really lots of weird stuff going on in some of these countries about their computing history and what machines are available and where they came from. So sort of try and define your targets. And then once you've done that, start reaching out, find the local equivalent of the Craigslist site. In Australia, it's Gumtree. Russia, Avito, Glovo, and some of the other Baltic countries. The Brits have their own version. So start before you're going, before you leave. Just get out there and start, researching, seeing what's available, making contacts with people. Because if you leave it till you get there, it's too late. You'll never be able to organize a deal. So that's one of the big things. So if you know you've got a trip coming up, start planning early and start making contacts. Also, it's good to check if there's any vintage computer groups in the area that you can make contact with, and they'll help you out. In Australia, there's some really active vintage computer groups. In Russia, it's interesting. There is a very big vintage computer scene, but it's not very organized. But there's lots of people out there. So go out, connect with them. I always took an empty suitcase with me, so to bring back stuff. Other ways to get it: eBay. You can find these machines on eBay, but just sort of be aware that shipping fees, postage takes forever, and you've got to make sure it's packed well, and because dealing with returns internationally and stuff with eBay is just not good. So sometimes it works out cheaper just to get a plane ticket and go. So, and the other way is direct contact. So, for doing that, I've made sort of contacts all around the world, and I've got a couple of friends in Ukraine that specialize in making add-on boards and replacement parts for some of the Soviet era machines. A friend in Australia that works on making replacement keyboards for the Micro Bs, because the Micro B keyboards were all crap. So if you find the Micro B, the keyboard's dead. Anyhow, as you make those contacts, it becomes easier, and they start to reach out, and you can communicate and all that sort of stuff. So, any questions around that? All right. Now, once you've got your machine home, you start to run into other considerations. So most machines are going to be 220 volts. Japanese machines will be 100 volts, but they seem to all run fine on 110, 120. That's usually okay. But most of what you're going to find is going to be 220 volts. So you're probably going to either need to convert it. Some machines have some really easy voltage conversions. The BBC, the Archimedes, and a few others have fairly easy voltage conversions. Some have external power bricks, like Amstrad and Sinclair's, so that just makes it super easy. But you may need a step-up transformer, depending on how eclectic the machine is. The other thing to be aware of, and we'll sort of get down to this point, is the frequency standards aren't the same. It usually doesn't make a big difference, 50, 60 hertz, but some machines do use the mains frequency for video timing and disk speed control. How I get around that with some of my machines is I actually just bought a 12 volt to mains power sine wave inverter for that country, and use that to power some of the machines that are sensitive to frequency, because that's the way you can get 50 hertz. So that's some interesting to be aware of. Next thing is, it's likely to be PAL. Anything from Western Europe or Australia is going to be PAL. Asia is all going to be PAL video, which is fairly easy to convert. So you can get, off Amazon, they sell little PAL to NTSC converters. Some handle CCAM as well, but they're pretty cheap. The Soviet machines are very hard to get stable video out of. They used CCAM, but it wasn't quite CCAM, because there's only two countries in the world that use CCAM, which is France and the former Soviet bloc. So work out what happened there. So they're really prone to interference, and that's why, like, if you look at my display, they're okay when they're, isolated at home alone, but you put them all together and the video's jumpy on all of them. So some other ways to convert the video is the Raspberry Pi RGB to HDMI shield. That's really handy. You'll probably have to make some of your own profiles, but some profiles are close enough that you can just modify them and get it right. The other thing is the GBS 8200, which is it's sold on Amazon and Alibaba and all those other things. It's a video converter board. It's really intended for arcades, but it converts. It does a pretty good job of converting any video to a VGA style output. So the local inverter and power supply we talked about, and the Amazon PAL NTSB converted. The other thing is cables. Some of the cables are very proprietary, and you're just not going to find them. And a lot of the machines you get are going to be missing some of them. So be prepared to do lots of Googling and trying to work out how to make your own cables. Google Translate's your friend with this. So All right. So now we'll get into talking about just some of the history of some of the machines I've got. So the Soviet machines are very interesting. In the Stalinist era in the Soviet Union, computers weren't, promoted or a big deal. They were sort of evil, product of capitalism. When Khrushchev came to power, he changed that quite a bit and encouraged local computer production. So in the 1940s, the Soviet Union started developing some of their own machines. And are often developed by competing ministries within the government. So they were all different. And even the same machines of the same model were different depending on where they were built. And you can even see it with some of the desktops, ones in my collection, is that the same machine was built at numerous manufacturing plants around the Soviet Union, and each one built at a different plant is different in some way. So that's sort of interesting. But anyhow, the lack of standards, they never caught up to the Western machines because, we sort of developed standards pretty early in the Western. So, and they didn't really have any good compilers, so everything was done in machine code. So, in the 1970, the ninth five-year plan called for increased computer hardware production, and they wanted 7,000 machines installed. And they had issues developing the homegrown machines, the compatibility, the differences, and all that sort of stuff. So they just said, we're going to copy the Western machines, which is what happened. So the first clones were IBM 360 clones, because IBM published the architecture for the 360. So that made it pretty easy for them. So even though it was patented, the architecture was available, so that was one of the ones they copied. If you've seen the Chernobyl miniseries, the Scala computer, that was a 360 clone. And the other thing is software piracy was really actively encouraged. It was... So in the 80s, the hobbyist development, in the Soviet Union, people were very creative and were able to use resources. So the hobbyist movement started to come out in the 80s. One of the first machines, the equivalent to the kits we had here, and, in other parts of the world, was the Radio 86RK. And the schematics were published in one of the ham radio magazines over there. So lots of people went and built this thing at home. It used a chip that was a copy of the Intel 8088, and it was the first sort of DIY computer. That sort of gained popularity. It was very, very, basic machine, but it was a good hobby machine. So, mid-80s, perestroika led to the development of the BK0010, which is, I've got one on my table. This was the most widely produced Soviet home computer, and it was really designed for use in schools. These things were still incredibly expensive, so, home computers weren't, very common. But it was used to expand computer literacy in schools. The BKs were based on the PDP-11 system on a chip. So they're actually PDP-11 compatible. The bus at the back is actually compatible with QBus electrically. It's not physically compatible with QBus, but it's electrically compatible with QBus. So there was a lot of PDP-11 clones floating around once they copied the PDP-11 system on a chip. So they'll run RT11 and other, operating systems for PDP, which is sort of interesting. The MC 0511 on my table is running RT11 as its operating system. So, yep, the PDP-11 clones based, the DEC chip, the DVK3 that's on my table, and the UKNC lines were all PDP-11 compatible, which was sort of powerful for the time. It was interesting that the UKNC, the MC0511, actually has two of the PDP system on the chip. So it uses one as a peripheral controller and one as a CPU. So, and they still had some production issues, so the quality wasn't great. They're all hand assembled. They're really interesting to look at because when you open them up, it's all hand soldered, hand wired. So it's pretty interesting. Then they started making some XT clones, so the Electronica MS or MC, depending on your translation. 1502 was XT clone, so runs MS-DOS, and they had their version of DOS called Sigma 4 DOS that was sort of popular, but it was mostly compatible. So it's just almost a PC Junior clone. It's got some PC Junior video aspects to it, TND 1000 type video compatibilities, but it also has its own thing. And towards the end, they started importing customized computers for use in education. So one of the machines on the table, the Yamaha KYB2, is actually an MSX2 compatible machine that was contracted to be built by Yamaha for the Soviet school system. And it had a specialized network card in it, so they could network them in the classroom. Also sort of interesting and sort of random and disconnected is the Micro B, that's an Australian computer, was also sold to Soviet schools. So it got a little bit interesting. And the MS 1504 was the only laptop ever produced in the Soviet Union, so it was the only one. That one's extremely rare. I don't have one. I've seen one. It almost looks like an early Toshiba with a worse screen. In the 80s, they were pretty close to the collapse of the Soviet Union. So basically at that point, everything opened up. They got imports. They started getting IBM compatibles, and everything sort of became normal as restrictions were lifted in 91. So one of the computer plants in Minsk switched to production of chandeliers from computers. So, and have to be sort of careful. A lot of these machines, they're Soviet Union, so they're not Russian. Like, a lot of my machines were built in Ukraine. So you'll actually see an Electronica on the startup screen. It says Kyiv. So you have to sort of disconnect the Russian thing from that, because they were Soviet Union. So British machines, these are pretty easy to find if you want to go out and find them, and some of them were sold here, so they were pretty, they're not too hard to find. Spectrum just was a low-cost home British computer, and there's lots of them around, and we had the Timex Sinclair, which was a version of a Sinclair over here. Then Acorn was a big British computer manufacturer who actually now is mostly in your phones as a spin-off with ARM. But they produced the BBC Electron, which was another sort of cheapish home computer. And then the British Broadcasting Corporation in the early 80s decided that they were going to do a computer literacy project. And it was a series of 3 television series about computers. and they wanted a computer to certain specifications for use in its program. And they put out these specifications and put out bids, and Acorn won with a BBC Micro. So that's where that came from. And because it was, spec'd for television shows, it had really great video. It was really expandable. Like, the amount of expandability in the BBC Micro is fairly impressive. It actually has a tube port where you can attach other processors. And that's where the ARM was actually developed. So the ARM CPU was developed off the tube port off a BBC Micro. So they were good machines. They were well built. They're solid. They were used in schools in Britain and Australia and other places. They were networkable. Some of my first computers memories are a logo on a BBC Micro in a lab at school. They were sold in very small quantities in the US, but in the UK and Australia and stuff, they're still pretty easy to find. And they're generally pretty reliable. If you find one, it's most likely to work. From that, Acorn developed the Archimedes, which was the first ARM-based machine. It was way ahead of its time. I'll probably get shot for this when I'm going to say it's the better Amiga than the Amiga. It really was. And it was the first real deployment of the ARM processor. And it was used heavily in schools. RISC OS, that you can still download and run on your Raspberry Pi, was developed for Archimedes. They're fairly cool machines. Unfortunately, they suffer badly from battery leakage. So if you find one and it's working, get the battery out of it straight away. Otherwise, both of mine have needed repairs from battery leakage, and it was all sort of fairly aggressive. So just sort of be aware of that. Then we had Amstrad, which were fairly popular. They were also rebranded in Germany as Schneider. The one I have is a Schneider version. Same machine. Amstrad was they were a big British electronics retailer, but or producer, but they didn't really produce anything. They rebranded, poor quality stereos and stuff, and that's how they got their start. So they sold a lot of them. They're fairly popular as home computer. They're fairly capable, so they're fun. The Australian machines that I have, Micro B, and there were several versions of the Micro B. It was actually interesting. They have a main board that's the same across all the models, and then they have a core board that sits on top of the main board, and there were several different versions. So there was one with static RAM and ROMs, and then there was the network-based version for one in schools, and then there was one with disk controllers and one with color and all that sort of stuff. So Micro B was originally a kit. The company that made the Micro B was Applied Technologies in Australia, and it was an S100 Z80 based kit that they produced, and then they won a bid from the New South Wales, which is a state in Australia, Board of Education, and developed the Micro B. So that was developed for Australian schools, and was really common in schools. Now they're really hard to find, getting ridiculously expensive for what they are. For some reason, they were exported to Sweden. I don't know why they were exported to Sweden. And they were also ended up in some Soviet Union schools at in the 90s. So other Australian machines, which is actually my target for my next trip back to Australia, was Dick Smith machines. So Dick Smith was a Radio Shack equivalent in Australia and New Zealand and some Asian countries. They were, had kits and direct competitor to Radio Shack. Sorry? No, no, no. It didn't end well for Radio Shack either. They both ended up in the same spot. But they sold their own lines of computers that were manufactured by other companies, but they were straight out clones of either Tandy machines or Apple machines. So they had the Super 80, which was a TRS 80 compatible, and then they had the Cat series, which was Apple II compatible. And they were the Apple II ones were lasers that were rebadged. So I'd like to try and find some of those. They're a little hard to find, but they actually got into some trouble from Apple for copying things, but because they were unlicensed. But I'm not quite sure how the settlement worked out, but they kept selling them for a while after that. So Japan was another interesting place where computers took some funny turns. So due to their kanji character set, it was very hard to do on any Western computer because it was graphical. So that led them to developing their own machines. And it started with a Fujitsu mainframe. And Fujitsu still makes these things in Japan. Because the Fujitsu mainframe could do the kanji character set. And they developed it. So they're still actually in use quite a bit in Japan. And some of the newer ones are actually based on Spark CPUs, so Sun CPUs. And Fujitsu made Solaris Spark compatible machines. I think they're probably the only ones keeping the Spark alive right now. That was one of them, and then NEC developed the PC88 and the PC98 series. That were the PC88 was Z80, the PC98 was x86 based machines, and they had DOS/5 or DOS/5 that could support the kanji character set. But they also are sort of MS-DOS compatible. They're proprietary in their expansion buses and all that sort of stuff. But they will run, DOS software. And they've got some specialized graphic modes, so there was a lot of games for developing for them. Unfortunately, a lot of the games for the PC98 are 18 plus. So yeah, so be careful when you're looking for games for the PC98. And then once Windows started to become available with Windows 3.1, as a graphical user environment, so it was much easier to support the kanji character set. So these machines sort of just migrated into more DOS machines and ran Windows. MSX was another one that was very popular in Japan. It really wasn't developed in Japan, but MSX was a standard developed by Microsoft. And, it became very popular. Yamaha, NEC, Sony all made MSX machines. And there's a few of them floating around. There's a few of them out on the show floor. So, cool. All right. Got through this pretty quickly. But here's some additional resources on some of the Russian machines. So, zxpk.com is a Russian forum. It's really great for support on any of those European machines, especially the Spectrum clones. That's the ZX in the name. Have to use Google Translate, mostly. It's got good resources on all those Eastern European machines, especially the Speccy clones. The UK, that's about the UK NC.nara.ru is information on the UKNC, which is the 0511, the PDP-11 compatibles. And then if you go to BK11, BK machine, this is where you can get all the software for it. There's emulators for all these machines if you want to play with them. So that's a sort of good way to get into it. You can play with the software. So, all right. Questions? Yep.
You mentioned that the kanji system isn't necessarily read or wasn't read very well by Western machines at first. Is that sort of still true today? And why, let's say, if you were trying to base play a game, let's say from Japan, you have to like change the location settings?
Yeah, not as much because we're all in, we all have graphical user environments now that can handle graphical to character sets. The big challenge was with text-based modes, having a character set like kanji was really hard to do because it's so many characters and it's very graphical. So
I can
yeah.
add the
Yeah.
story for it. So the DOS-B is the original DOS version that runs on IBM PC, basically PC clones that support the Japanese kanji.
Yeah.
Which basically it means that the DOS-B has the Japanese font as a file. And then this basically video subsystem to display the screen in a text mode support the Japanese character. So if you can get the DOS-B in US, you can technically run the DOS-B on the US machine.
Thank
Yeah.
you very much.
But
And then the
but it actually runs in a graphical mode, correct?
well, it's a
Yeah.
basically it runs in a graphical mode. So
Yeah.
basically everything is running in the VGA graphical mode.
Yeah.
Rendering the text.
Yep.
So PC98 is not really using DOS-B. It's basically NEC own version of DOS,
Yeah.
which is totally incompatible with the from the API perspective, DOS is DOS, so
Yeah.
it's basically compatible. But
Yeah.
it doesn't have it's actually PC98 hardware supports the Japanese character on a read-only memory. So basically, the machine itself is reading the font from a read-only memory to display in a screen. So that's kind of things.
Yeah.
What about hiragana? I thought that was the main text.
Well, in Japanese there are three different character types. One is the hiragana, one is the katakana, and also kanji is a whole chunk of the 65K sets of for characters.
Yeah.
So in katakana was originally supported by many machines because there is a character set called one side of the character set called ASCII character is a 0 to 7F in a hex mode, and on above that 80 to 8, FF, Japan assigns the katakana character set on there, so that many Japanese machines support the upper side of the ASCII. Instead of it's like a European characters. If you think about the European characters, 0 to 7F is just regular ASCII, and 80 to 8F. FF is the basically European characters. In the same notion, Japanese does the katakana set, supporting the 80 to 8FFN, so that if you have a Japanese machine and it has a character almost font set, you can display those characters in some machines.
No, thank you. No, that was no, thank you very much. That was all good. So, yeah, definitely a lot more detail there. So that was all good. Yep.
Do you find different or unusual media formats with these machines, or do you find that they copy standards?
The media formats are generally pretty much the same. I've not really run into problems, and actually most will work with GoTex and stuff like that. So, trying to think of anything that had any sort of odd media, but not really.
You mentioned the machines that were originally clones of OS 360 and
Yeah.
I would expect them to use the same media standards.
Yeah, yeah, they all had tape and all that sort of stuff.
Why invent something new?
Yeah. And it was actually interesting in the Soviet Union, like different countries within Soviet Union had different specialties. So like some were good at making disk drives, some were good at making printers and all that sort of stuff. Yeah.
in Russia or Soviet Union, in the former Soviet Union, do they use the same kind of chips, or do they have their own set of the LSIs? And usually we use the 74 LS.
Yeah. So what's interesting in the Russian machines, they're all copies. So you can almost always find a Western equivalent for the Russian chip, and that you can, so all the 7400 series, there's direct pin compatible replacements. Same with the memory DRAMs. There's pin compatible Western. Yeah.
How is the performance different between those components if they were made, let's say, in Russia as opposed to the United States?
Not really. Their version of the 8088 runs at 5 megahertz, so it was a little faster, but yeah. So the chips are interesting. Their packaging was all sort of different. So you get, some of them have like open frames, so you can actually see the connections to the die. And so that's sort of interesting. And some are ceramic. And some are just regular Western style packaging. But it was interesting to see some of their packaging because they're actually really beautiful chips, some of them, when you look at them with their packaging.
Have you got any of the speak for video stuff?
No.
Some of that in New Zealand?
Yeah. So. Cool. All right. Well, if there's no more questions, have a good time. Enjoy the show. Make sure you check out everything. And
Thank you.
all right. Well.